The last plot that we'll make for this course is called a heat map. For our data set, we want to display each combination of gene and sample case, the difference in gene expression in the sample from the baseline. We want to display combinations where a gene is overexpressed in red and combinations where it is underexpressed in blue. Here's the code to make that heat map. First, we'll run all of this in order to melt our data to a long format. And then we just run our ggplot code using the geom tile. Now, this last line is going to give us a scale gradient, and we're going to use the colors from blue to red. So let's see what the output looks like. And there's our heat map. Even with such a dense display, we aren't looking at all of the data. In particular, we're just showing the first 200 genes. That's 200 genes of over 6,000 of them. And since this data set was produced, genomic data sets of these kind, sometimes called microdata, are only getting larger and more complex. What's most interesting is that other data sets also look like this. For example, internet companies run lots of randomized experiments, where in the simplest versions, users are randomly assigned to a treatment, like a new version of a website, or some sort of new feature or product, or a control condition. Then the difference in outcome between the treatment and control can be computed for a number of metrics of interest. In many situations, there might have been hundreds or thousands of experiments and hundreds of metrics. This data looks very similar to the genomic data in some ways, and this is why the useful maxim, plot all of the data, might not always apply to a data set as it did for most of this course.